Today we'll be explaining 2006 Form B question number 5.
So first, Part A. Part A asks us to find y equals f of x. First, we'll start with the differential equation dy dx equals 2y times 3 minus x. The first thing we need to do is multiply both sides by dx. So our dx's will cancel over here. Our next step is we need to divide both sides by y. This will leave us with dy over y is equal to 2 times 3 minus x, and then our dx comes down. dy over y is equal to 1 over y dy. So we'll just go ahead and substitute that in. So our next step is going to be taking the integral of both sides. So the integral of 1 over y dy is equal to the integral of 2 times 3 minus x dx. Before we take this integral, we're going to want to distribute our 2 and make this a little bit easier on ourselves. So we have the integral of 1 over y dy is equal to the integral of 6 minus 2x dx. So when we take the integral of 1 over y dy is the ln of the absolute value of y. And our integral of 6 minus 2x is 6x minus 2x squared all over 2 plus c. Now our next step is to cancel out our 2's, which will leave us with ln of absolute value of y is equal to 6x minus x squared plus c. Now what we need to do is eliminate our ln. In order to do that, we have to e both sides. Then we'll be left with we'll be left with y equals e to the 6x minus x squared plus c. Our next step will be moving our c to the front, which will leave us with y equals c times e to the 6x minus x squared. So the problem tells us that f of 4 equals 1, meaning that when x equals 4, y equals 1. So what we need to do is plug in 4 for every x that we see and 1 for every y. So that would leave us with 1 equals c e 6 times 4 minus 4 squared. 6 times 4 is 24, and 4 squared is 16. 24 minus 16 equals 8. So that leaves us with 1 equals c times e to the 8th. Our next step is trying to get c by itself, so we're going to have to divide by e to the 8th. This will leave us with c equals 1 over e to the 8th, which is also equal to e to the negative 8th. Now that we've solved for c, we need to plug this back into our original equation. This will leave us with y equals e to the negative 8th times e to the 6x minus x squared. And since we have like terms here, we need to combine them, and our final answer will be y equals e to the 6x minus x squared minus 8.
So part B says, given that g of 4 is equal to 1, find the limit as x approaches infinity of g of x, and limit as x approaches infinity of g prime of x. So to find the limit as x approaches infinity of g of x, we look at the logistic differential equation dy dx is equal to 2y times 3 minus y given in the problem. We know that the basic form of logistic differential equation is dp dt is equal to k times p times L minus P. L is the carrying capacity of a function, and since our logistic differential equation given in the problem is in this form, we know that the limit of the function as x approaches infinity is 3. Part B also asks us to find the limit as x approaches infinity of g prime of x. We know that a standard logistic function looks like this. As it approaches infinity, it gets closer to a number without touching it. In this problem, the function approaches 3. And since the derivative tells us slope, and the slope of the function as it approaches 3 is getting smaller, the slope is 0. So the limit as x approaches infinity of g prime of x is equal to 0. So part C asks us to find for what value of y does the graph of g have a point of inflection. A point of inflection is where the second derivative is either 0 or undefined, meaning the original function changes concavity. To find this, we must first take the derivative of the function. dy dx is equal to 2y times 3 minus y. So to do this, you have to use the product rule, which is the first times the derivative of the second plus the second times the derivative of the first. So first, we must take the derivative of dy dx, which is going to be d squared y over dx squared. Then we're going to do the product rule. So first times the derivative of the second, which is going to be negative dy dx, because the derivative of a constant is 0, and the derivative of negative y is just going to be negative dy dx, plus the second times the derivative of the first. Next, we have a dy dx here and a dy dx here. So we're going to bring that out front, and we're going to be left with d squared y over dx squared is equal to dy dx times negative 2y plus 3 times 3 minus y. We're going to distribute this 2 right here, and be left with d squared y over dx squared is equal to dy dx times negative 2y plus 6 minus 2y. So we have a common factor right here. So d squared y over dx squared is equal to dy dx. Combine like terms. Negative 4y plus 6. And I'm just going to bring this dy dx to the back. You don't necessarily have to do that, but I just think it looks better. And then I'm going to bring this 6 to the front and make it 6 minus 4y just to get rid of this negative in the front. So I'm going to be left with d squared y d over dx squared is equal to 6 minus 4y dy dx. So we have to find the point of inflection, and we know that dy dx is never going to equal 0. So the only way to find the value of our point of inflection is when 6 minus 4y is equal to 0. So to do this, we're going to subtract 6 to the other side, and we're going to be left with negative 4y is equal to negative 6. So we're going to divide negative 4 to both sides. So, and these negatives are going to cancel out, so we're going to be stuck with y is equal to 6 over 4, and that's the same thing as 3 halves. So our point of inflection is at 3 halves. Part C also asks us to find the slope of the graph of g at the point of inflection. So to do this, we evaluate the function dy dx is equal to 2y times 3 minus y at 3 halves. So we're going to plug in 3 halves for all of the y's that we see. So when we do this, we get dy dx is equal to 2 times 3 halves times 3 minus 3 halves. Well, these 2's are going to cancel right here. So dy dx is equal to 3. And 3 minus 3 halves is just 3 halves. So we're left with dy dx is equal to 3 times 3 halves, which is 9 halves. So the slope at the point of inflection is 9 halves.